When people switch to Linux, one of the first questions they ask is simple: can I still run my Windows software? And for years, the answer has been exciting. Yes, you can. Thanks to compatibility layers, translation tools, virtualization, and containerization, running Windows applications on Linux has never been more possible than it is today. Tools like Wine, Proton, Play on Linux, Bottles, and even full virtual machines. But after years of experimenting, testing, optimizing, troubleshooting, and trying to force Windows applications into a Linux workflow, I stopped. Not because it's impossible, not because it never works, but because the long-term cost, instability, performance, time, and philosophy became too high. This is not a story. This is a breakdown of the real, technical, practical problems that come with running Windows software on Linux in 2026, with proper examples of where things fail, why they fail, and what that means for serious users. The first major problem is compatibility inconsistency. Wine is not an emulator. It translates Windows API calls into POSIX equivalents in real time. That means behavior depends heavily on how a specific application interacts with Windows internals. Some applications work perfectly. Others partially work. Others crash on startup. And sometimes an application works today and breaks after a Wine update. Take Adobe Photoshop, for example. Older versions such as CS6 can sometimes run with heavy tweaking. But modern Creative Cloud versions depend on complex DRM, background services, and deep system integration. Even if you manage to install it through Wine, GPU acceleration may fail, fonts may render incorrectly, plugins may break, and updates can completely destroy the installation. This isn't just inconvenience, it's workflow instability. The second issue is updates. Windows software expects a Windows environment. When a developer pushes a new version of their application, it's tested on Windows 10 or Windows 11, not on Y9.X running under a specific Linux kernel version with a certain glib build. An update can introduce new API calls that Wine hasn't implemented yet. Suddenly, software that worked yesterday no longer launches. Consider Microsoft Office. Office 2016 might run decently under certain Wine configurations, but Microsoft 365, with its cloud sync services, OneDrive integration, and constant background authentication checks, is far less predictable. Authentication pop-ups fail. Clipboard behavior becomes inconsistent. Outlook integration breaks. And when your productivity suite becomes unreliable, that's not acceptable. The third issue is performance overhead and graphics translation layers. In gaming, Proton has done something incredible. Steam titles often run near-native performance thanks to Vulkan translation via DXVK. But even there, edge cases exist. Anti-cheat systems like Easy Anti-Cheat or BattleEye can block Linux users entirely. Competitive multiplayer titles may simply refuse to launch. For non-gaming applications, GPU acceleration is even less reliable. Programs like DaVinci Resolve actually have native Linux versions, but Windows-only editors like Adobe Premiere Pro struggle heavily under Wine. Hardware encoding, CUDA acceleration, and driver-level optimizations are unpredictable. Even when something runs, it may not run efficiently. The fourth issue is system integration. Windows applications expect Windows file paths, registry entries, system services, and device handling. Wine creates a fake C, drive, a pseudo-registry, and emulated DLL environments. But it's still a translation layer. File associations don't always behave naturally. Drag and drop between native Linux applications and Wine apps can be inconsistent. Printing support may require extra configuration. Audio routing can break if Pipewire or Pulse Audio configurations change. Professional software amplifies these problems. Consider AutoCAD. Engineers depend on precision rendering, hardware drivers, and plugin ecosystems. Even if a version runs under Wine, industry-certified workflows often require official support. If something goes wrong in production, there's no vendor support for running it under Linux compatibility layers. That alone is enough to stop professionals from relying on it. Another major issue is security architecture mismatch. Windows software often depends on Windows-specific security models. For example, certain enterprise tools rely on Active Directory integration, Windows Hello authentication, or kernel-level drivers. Kernel drivers simply do not function under Wine because Wine operates in user space. Software that requires driver installation, like certain VPN clients or hardware dongle licensing systems, will fail outright. Take SolidWorks as a case study. It relies on low-level graphics driver interaction and sometimes hardware-based license verification. Even if you could trick the installer, stability would be questionable. Crashes in design software aren't minor inconveniences, they're productivity killers. The fifth issue is dependency hell within compatibility layers. Each Windows app might require a specific .NET version, specific Visual C++ redistributables, certain DirectX libraries, or proprietary components. Wine prefixes can isolate these environments, but managing them becomes a full-time job. Bottles tries to simplify this with pre-configured environments, but complexity scales quickly. If you run 5 different Windows applications, you might need 5 separate wine prefixes to avoid conflicts, each with different DLL overrides, different runtime libraries, different tweaks. Maintaining that setup over years becomes fragile. The sixth problem is input behavior and UI scaling. High DPI displays expose major inconsistencies. Windows applications may not scale correctly under Linux compositors. Text becomes blurry. UI elements appear misaligned. Multi-monitor setups sometimes cause window positioning bugs. These aren't dramatic failures, but they degrade daily experience. For example, running FL Studio under Wine is possible. Many music producers do it, but MIDI device recognition can be inconsistent. Audio latency settings require extra tuning. Plugin VST paths sometimes break. Native Linux alternatives like Ada or Bitwig avoid these translation issues entirely. The seventh issue is background services and auto-start dependencies. Many Windows programs expect persistent background processes. Cloud Sync clients like OneDrive or proprietary launchers may rely on Windows Task Scheduler integration. While community workarounds exist, reliability isn't guaranteed. Game launchers illustrate this clearly. The Epic Games launcher can be installed via Wine, but updates often break it. Authentication pop-ups fail. Capture verification may not render correctly. Meanwhile, Steam with Proton is officially supporting Linux. That difference in vendor support matters. The eighth issue is debugging complexity. When a native Linux application fails, you debug Linux. When a Windows application fails under Wine, you debug 3 layers: the application, Wine's implementation, and your Linux system configuration. Error logs become cryptic. Searching forums leads to outdated patches from years ago. Solutions may involve obscure DLL overrides or registry edits. That leads to the ninth issue, time cost. The hours spent tweaking, configuring, reinstalling prefixes, and reading compatibility reports add up. If your goal in switching to Linux was efficiency and control, spending entire evenings troubleshooting a proprietary Windows app contradicts that purpose. The 10th issue is philosophical alignment. Linux is built on open standards, transparent development, and community-driven ecosystems. Running proprietary Windows software keeps you tied to vendor lock-in models. For example, instead of running Microsoft Office under Wine, switching to LibreOffice or OnlyOffice aligns better with Linux's native ecosystem. Instead of forcing Photoshop, using GIMP or Krita may require adaptation but offers long-term integration stability. This doesn't mean Linux alternatives are perfect replacements. GIMP is not Photoshop. LibreOffice is not a pixel-perfect Office clone. But native tools integrate better with system themes, file managers, permission systems, and package managers. They update through your distribution's repositories. They respect Linux file system conventions. They don't rely on compatibility hacks. The 11th issue is kernel-level anti-cheat and DRM escalation. As software companies implement deeper hardware-level protections, compatibility layers struggle. Windows software that installs kernel drivers for anti-tamper mechanisms cannot function in user-space translation environments. This gap will likely grow over time. The 12th issue is virtualization trade-offs. Running a full Windows VM solves compatibility, but introduces resource overhead. You allocate RAM, CPU cores, disk space. GPU pass-through is possible but complex. And now you're effectively running 2 operating systems simultaneously. That's not integration, that's coexistence. The 13th issue is long-term sustainability. Wine development is impressive, but it's reactive. Microsoft changes ARPAs. Wine implements them later. It's a continuous catch-up cycle. Native Linux software evolves with the Linux ecosystem itself. There are exceptions. Some Windows programs run flawlessly. Older productivity tools, lightweight utilities, certain indie games. But building a critical workflow around compatibility layers introduces risk variables that professionals eventually eliminate. The final realization is simple. If you're constantly running Windows software on Linux, you're not really migrating. You're emulating your old workflow. True migration requires adaptation. It requires evaluating whether native alternatives meet your needs, even if they differ. Stopping the practice wasn't about ideology. It was about reliability, predictability, reduced troubleshooting, lower maintenance overhead, cleaner system architecture, and embracing software built for the operating system you're actually using. Linux is powerful enough on its own. When you rely on native tools designed for it, the system feels cohesive. When you stack translation layers to replicate Windows behavior, you reintroduce the complexity you tried to leave behind. That's why I stopped running Windows software on Linux. Not because it never works, but because over time, the problems outweighed the convenience. In 2026, Linux doesn't need to pretend to be Windows. And the more you let it be itself, the more stable your workflow becomes.